All right, up next is David Smith, who many of you probably know. He's probably one of the few people in here who was also using R back when it was called S. And I'm interested in this because I deal with transactions coming at us very quickly, but the stuff you're talking about is like distributed as well, right?
Yes.
Yeah, so very exciting stuff. Help me welcome David.
Thanks. Thank you, Josh. I just want to say, as we get going here, I want to give just a word of thanks to all the speakers. This has been a fantastic conference so much this year. I've learned so much and really enjoyed it. I hope I can meet that same standard. But I have a... No, I'm fine with the clicker. Thanks. So let me get this up on the slide so that's there. Very good. Alrighty. So I've got a pretty ambitious goal today. My goal is to take a model that you've developed in R, just any kind of model that generates a prediction from a row of data. And I want to make it possible to generate predictions from that model at a really, really high rate. And I'm talking here, I want to try and get to 1 million transactions a second. And I'm going to do it live. I'm going to do it with a remote server on not my own Wi-Fi, so wish me luck on that front. But this could be any kind of a model. So it could be a model that is giving you an optimal price to make a bid on an option. It could be a model that in real time is trying to detect regime changes in the market. It could be a model that is running against live credit card transactions on the banking side, for example, to detect fraud. In fact, you might notice that previous example was the one that I promised to give you in my abstract. I'm actually going to switch it up and use a different data set. It's going to be a loans data set to try and predict loan delinquency for reasons I'll explain a little bit later on. So let's assume that you've actually gone through the process of building a predictive model. And just Clippy is not coming to Microsoft. This is a joke, just to be clear. The thing that I want to focus here on is not the process of building the model, but once you've actually trained it and got it ready to go, is what you do then. Because as General George Washington famously said, training a model is easier, but operationalizing it is harder. One of his lesser known raps, no Hamilton fans here? Okay. So when it comes to generating predictions from models, there's basically two modes you can do to go about it, of course. You could do it in batch mode in an offline scenario. Nobody's really waiting for these results. You're probably just uploading them into a database or something. Perhaps it's an overnight evaluation of portfolio positions, those kinds of things. But what characterizes these batch mode environments is you've got many rows of data to make predictions from, probably millions of them. You don't really matter too much about the time because you're probably doing it overnight, but the time it takes to generate these predictions is generally proportional to the number of predictions you've got to work with, so that could be minutes, maybe even hours, depending on what you're doing. That's not what I want to talk about here today. I want to focus on real-time predictions from a model. And in this situation, you don't have millions of data points to work with. You just have what's actually available at that very time. It might just be one credit card transaction that's available to you, maybe a few, because you gather them from many different clients at the same time. But we're talking, 1, 2, 5, 10, 100. We're not talking thousands or millions here. The key thing that I'm trying to optimize here, in addition to the thing we're predicting itself in the model, is latency. The amount of time between when we get the row of data to do the prediction on and when we can return back to the client. And of course, thinking about real-time scenarios, at the endpoints, think you've just put your credit card into a point-of-sale machine somewhere, someone somewhere is evaluating whether you're a thief, but you want to get that response for that fraudulent transaction back to the point-of-sale terminal in just a second or so. And that's from my point of view as someone at the endpoint. But from the server's point of view, there could be many hundreds, possibly thousands of those processes at any one time. So the server has to process that request in just a few milliseconds. So how can we actually make that work with models that you generate using R? Now, I'm sure many of us have been in this situation before, and you might have done things like developed the model in R, exported out the parameters from that model, and then wrote some code in C++, or Java, or some other real-time system to actually process that model independently of R. You might have used a system like PMML or whatever, but what these things have in common is that there is a development process that has to happen between when you actually build the model in R and when you operationalize it in the real-time system. It'd be much, much nicer if we could just use the R code that we've already used for training the model and the functions that we already have, like predict, for generating predictions or scores from that model, and use that in the real-time environment. And I'm going to show you a couple of ways that we at Microsoft have developed to do exactly that. The one I'll be focusing on today is taking that R code and that R model and then deploying it as a web service within a server running Microsoft R Server, which is just R with some additional packages that I'll describe in a minute. And also another option, if you're working with data that lives in SQL Server, is to deploy it as a stored procedure within SQL Server using that same R code. Behind the scenes, this is using exactly the same technology, just two different ways of deploying it into two different platforms. So, as I mentioned, I'm going to be using the Lending Club data. For this, you might be familiar with it. If you're not, there's a link here where you can find the data, and also a blog post that the data science team at Microsoft did exploring this data, pulling out just 7 columns actually, from the 50 or so columns that are available in it that I'll use in this demo, and including one generated feature, which is whether or not the loan ultimately was delinquent, as determined, as you can see there. And this data is actually included in something called the Microsoft Data Science Virtual Machine, which I'm going to be using in my demo as my remote server. But this is the architecture that we're going to be using for operationalizing a model to predict this loan delinquency using Microsoft R Server. I'm going to be working here, is my cursor coming up? There it is, yep. I'm going to be working here on the left-hand side from a client. In this case, that's going to be this Surface Book laptop that I'm working with here, where I'm going to develop a model and then publish that into a server. That server there in the middle is going to be an Azure Data Science Virtual Machine running in the cloud. You can see the specifications of that there, and we'll be publishing that model into it. I'll also mention that when it comes to consuming that model that I've published, I could also do that from R itself. You might have quants, for example, that want to access those models that you've published directly from features within the R language, and that's certainly possible. It's not the scenario I'm going to focus on here. I'm going to assume it's actually an application that is actually going to consume those models, pass rows of data into it, and then generate those results and incorporate it into an application somehow. All right. There are two, in addition to there being two platforms you can use, Microsoft R Server or SQL Server, to do the deployment. There are two different modes as well. One we call flexible deployment, and that actually works for any arbitrary R function or package. So you can use anything from CRAN, any built-in R function. And the way that works is when we publish this model, as we'll see, an R interpreter is actually spawned on demand to do your calculation and return the result back through the web service. And as you'll see in a moment, I'm going to use a function called publish service in the MRS deploy package, which comes with Microsoft R, with a service type of script to do that. I'm also going to be showing you a very new technology which just came in the most recent release of Microsoft R called real-time deployment. And this doesn't work for any arbitrary R code. It just works for specific models that we have included in a couple of packages called ReverseScalar and Microsoft ML. But if you are using those particular types of models, instead of publishing R code, you can just publish the model object. And then we use the same prediction code that we have within R at the endpoint to actually generate the predictions from the model without actually calling into the R interpreter itself. We kind of bypass R that way. So things are a lot quicker, and we call that a real-time deployment. All right. And just for reference, I'll make these slides available on the blog after the talk. These are the set of models that you can use for that real-time deployment. These are all Microsoft's implementations of models types you're familiar with. They're distributed, they're parallel. On the training side, they're very fast. And now on the scoring and deployment side, they're very, very fast as well. I also mentioned, especially with the reference to Seong Kim's talk yesterday, there are also a couple of functions in there for doing things like text sentiment. scoring, and also image featureization. If you're working with image data, some cool stuff you can do with those, which I'm not going to talk about today. All right, let's go ahead and jump into my demo. All right, I'm going to start with RStudio. So here I have RStudio, but the R engine that RStudio is running here is Microsoft R Client running directly on this laptop here. The data is living in a cloud server on Azure, and it's sitting in SQL Server. So the first thing I'm going to do is load the RevoScaler library from Microsoft's R Client. There's a connection string which specifies how I can log into the SQL Server, and then I'm going to import the data and build a random forest model against it. So right now it's logging into the server, it's importing the data just as a regular data frame. It's about 850,000 rows or so. The next step here, this is actually the default, but I put it in here just to make things clear, is I'm going to do the computations for training the model here directly on this local laptop, and I'm going to use the RxD forest function to do that, which is provided by Microsoft R Client and Server. And as you can see, it's chunking through the data pretty quickly here. I'll also mention, just while it's going, that I did have the option, if I'd wanted to actually skip the whole step of importing the data. I could have actually done the training of the model over in the remote server, which is much more powerful, as we'll see, just by changing one line of code, which is this set compute context. Just to say, do the computation within SQL Server rather than my local laptop, and then process the data against not a data frame on my local machine, but an actual query over in SQL Server. But as you can see, that's done now. I've got a random forest model that I can work with. And as George Washington said, it's easy. Of course, I'm skipping all the details of building a model. I'm not validating this, I'm not training it, but this is just a model object I can work with for my demo. The next step I need to do is take this model and publish it over into the web service. And for that, I'm going to use a library called MRS Deploy. I'm actually going to log in to that R engine that's sitting out here in the cloud now. So I mean, this is actually R somewhere else. For example, if I type sys.info here, you can see that it's actually running Windows Server 2012. It's a big machine. We'll see it in detail in a minute. So this is not local R, this is a remote R. There's nothing in it right now. If I type objects over there, nothing. I can type pause to get back. Now I'm running on my local laptop again. And what I'm going to do is take that model object we created called dForestModel and push it over to the server. And that's done now. All right, and I can prove that, in fact, just by going here, resume. I'm back on the remote cloud server now. And if you look at the objects, you can see that dForestModel object is over there. And that's the thing that the scoring process is going to use. So the next thing I need to do is publish services. And I'm going to publish one of each kind of service, a flexible service that just uses R code, and specifically the R code is going to use the RxPredict function just to do an explicit prediction from that object. There could have been a regular RPredict function if I was using a regular R model, but I wanted to compare both services here, which is why I did that one. So I'm going to go ahead, and a snapshot is just the environments, the objects that this model is going to need. The type of service is an R service. There is versioning. You can have different versions of these services available, but I'm just going to go ahead and publish that one right there. All right, so let's see if it works. I'm going to grab just one row of data here. So we're in a scoring environment, and then I can just call it like I can a regular function. Now that calculation didn't happen here on my desktop. It happened over in the server, and I got back a score, 66% chance of fraud for this particular row of data that I looked at. And just to compare against calculating it on my local machine, you can see I get the same result as I would expect. And for comparison purposes, I'm also going to publish a real-time service. And in this case, rather than publishing a line of R code, the only thing I publish is the model object itself. And I call that a real-time service. So exactly the same thing, but just publishing the model object. Different name for the service, because we're going to call it separately. But I can call it the same way, and I get exactly the same result as I did from the flexible service. So now sitting in the cloud, I have a RESTful API. It's based on the Open API standard running in a service called Swagger, which is an open source framework for setting up APIs like this. And Here I just called it from R. You can just see this as a moment ago that, within R I can call a service and get a result back. And so in the last second, I ran 1 transaction per second. So if I can scale that up by 6 orders of magnitude, then I'm getting to where I want to go. But I don't want to do that from R. What I'm actually going to do is use a separate client, and hold your breath, I am actually going to use Python as my client here. I've never given a Python demo before. I barely know Python. So thank you to Pratik at Microsoft for helping me set up this client. Just show you the code for those of you that might know Python better than I do. It's just looping through, generating a bunch of requests at this service. It's pulling them up 100 at a time, and then setting up a bunch of simultaneous threads to try and load up the server. But I can show you that working. It's Python predict client.py. So now it's just pushing a whole bunch of simultaneous requests against that remote server, and once the handshake is complete, we'll be able to see that using the regular flexible service with NER code, it's getting 1.9, 1.7 thousand a time, whereas the service where I just used the model object that's bypassing R gets a speed performance of about 1.5 to 2x, kind of depending on how it runs. So we're getting up to, in the 3,000-ish range, which is nowhere near where we need to be yet. One of the reasons is because there's a lot of latency between here at UIC and that remote server. And if you're building a real-time operation, you do want to have the client as close to the data as you can. So I'm actually going to pop over using remote desktop to, there we go, to the remote server running in Azure. And you can see that from the RDP little toolbar up there that shows me I'm sitting over in Azure right now. So I'll tell you the thing, I've got a version of that same script, Python. Oops, no, that's the wrong place to press tab. Python predict client, there we go. So this is that same script, although I'm upping the number of requests I make at the same time, doing 20,000 requests at a time here. And from the regular flexible service, we're getting about 80,000 per second, so getting better. Whereas with the flexible service, now with the client very close to the server, we're getting up to about 200K per second. So we're making some good progress, but we're not quite there yet. So I've got a different version of the same script. Again, Python. Actually, I can just do it this way. Predict client2.py. I'm just going to up the rate even further, and I'm only going to use the real-time service this time, just so I can focus on the really high-performance one. And if I send, I think this is going to go up to 100,000 requests per iteration. I should be getting closer to 560,000. It'll keep on going, but it's not going to get to 1 million. And the reason why is because Python isn't fast enough to actually generate enough requests. Yes, I said it, Python isn't fast enough. So in order to actually generate enough requests that I need, what I'm going to do is actually run 3 simultaneous Python examples. So I'm going to run another client again. So in this one, you can see my utilization's up to about 74% on my 32-core server. The first request is doing about almost 500,000 a time. This one is 460, so we're not quite up to the million. So let's push it and do one more client. I've got 3 simultaneous clients right now. And so we got 490 at this one, 473 at this one, so about 950 or so. Adding in the third client, we're going to get up to another 440, so about 1.3 million transactions per second, all being handled by this single 32-core server running out there in Azure. So that's pretty cool. So let me return back to my slides. Oh, these are just screenshots that you'll get in the slides when you receive them. In this particular example, you saw there was definitely an improvement between using the real-time service versus using the flexible service. The actual ratio you get is very dependent on lots of things like network latency, as we saw. It's also quite dependent on the size of the model object that you're working with. If you're working with an object with lots and lots of factors, mine just had 7 in this case, or a very complicated forest model, for example, you can get some quite dramatic differences between the performance of the real-time service versus the performance of the flexible service. And we've seen examples from 10x even up to 100x differences in the speed versus using the R engine versus using the model object alone. Now, in those examples, I was publishing the prediction service to Microsoft R Server using the MRS deploy package. I also wanted to mention to you that in situations where you have the data living in SQL Server, you could also publish those functions in much the same way directly into SQL Server within a SQL script. And it's essentially as a stored procedure. The process is much the same. From the client, you publish the model out to SQL Server, and the way you typically do that is to serialize that object into a binary string and then put it directly into a table where it can then be accessed by either the SP execute external scripts store procedure, which is the flexible version. You can use any R code in that environment, or the new SPRX predict store procedure, which will just look at the model object and do those computations in real time. And that gets me back to the reason why I changed my title a little bit for this talk, because when I submitted my abstract, all those eons ago for this conference, I had intended to base my presentation on a demo we gave back in September last year, which used the SQL Server mode of deployment on loan transaction data to generate 1 million transactions per second. I was going to redo that for you here. And as I was preparing for it, I suddenly discovered that this particular demo ran on a 192 core server, which is a physical server in a room and a network that I'm not allowed to have access to. So that was a bit of a bummer. So I decided to actually look at a different data set and try to do it in the cloud. But since we did this demo, the new real-time prediction capability came about. And as we just saw, because we've moved from the flexible version that was used for this older demo to the real-time prediction capability that we have now, I was able to get to that 1 million predictions per second benchmark using a much, much smaller machine. In fact, about 1/6 the resources. 32 cores instead of 92 cores, and about 1/6 the RAM. So that's pretty cool. But if you want to check out that previous demo, it's available right there on the blog as well. I'll also say that if you'd like to reproduce these examples, I've got a slide here that just shows you the two different deployment modes, whether it is in SQL Server or in Microsoft R Server, and then the two different deployments, the real-time versus the flexible operation modes. And you can see it's pretty simple the way you do it depending on those. So in summary, you can either use Microsoft R Server or SQL Server as the deployment platform. If you want to use any R code at all, you can use that flexible operationalization mode that I described to you. Or if you want to use the new real-time capability and your model is one of those lists that I showed you earlier on, you can use the new real-time operationalization section. If you'd like to try it, you can download the Microsoft R client for free at the link you can see right here. And you can also launch the Data Science Virtual Machine in Azure, which contains Microsoft R Server, SQL Server, the data, and all the bits you need to replicate what I did here. Also, I'd like to give thanks to Pratik Paladnikar and Arun Garunathan at Microsoft to really help me out with this demo, and to all of you for watching. Thank you very much.